Find sine of 11 pi over 12 and cosine of 11 pi over 12 using the half angle formulas. First thing I want to do is realize that 11 pi over 12 is 11 pi over 6 divided by 2. So we can use our half angle formulas with our original angle, and this using the x's over here. X would be 11 pi over 6, and x over 2 would be 11 pi over 12. So to calculate sine of 11 pi over 12, let's use our formula, which we have over here. Sine of 11 pi over 12 will equal either positive or negative, we'll have to check that in a minute, the square root of 1 minus cosine of 11 pi over 6 all over 2. And let's see, what is cosine of 11 pi over 6? Quick look at our unit circle. 11 pi over 6 is here, and our x value at that point is the square root of 3 over 2. So cosine of 11 pi over 6 is going to be the square root of 3 over 2. That's all over 2. And now we've got a bunch of fractions to clean up. 1 is 2 over 2 minus the square root of 3 over 2. So that gives us plus or minus the square root of 2 minus the square root of 3 over 2 over 2. Make sure that we make it obvious the radical covers everything. That gives us the square root of 2 minus the square root of 3 all over 4. And we can simplify this because square root of 4 is 2. So now let's determine whether this is positive or negative. If we're in 11 pi over 6, we said is down here in the fourth quadrant. So we're between 3 pi over 2 and 2 pi. And if we cut all of these in half, we get that x over 2 is between 3 pi over 4 and pi. So that's going to be a second quadrant, and we know in the second quadrant sine is positive, so we will use the positive version of this. So that gives me sine of 11 pi over 12 is the square root of 2 minus the square root of 3 all over 2. We can do the same with cosine. Turns out most of our math is the same. Notice the only difference here is the minus and the plus. So all of this simplifying we did is going to be the same. And we get cosine of 11 pi over 12 is either positive or negative square root of 2 plus the square root of 3 all over 2. And in the second quadrant, cosine is negative, so this is going to be using the negative version. And we get cosine of 11 pi over 12 is equal to negative square root of 2 plus the square root of 3 over 2. I know this looks weird. We're not used to seeing radicals inside radicals, but that's one of the side effects of this formula, is that this can happen. Let's move on to another example. If sine of theta is the square root, is 3 over the square root of 13, and theta is in quadrant 3, what is cosine of theta over 2? So we got a couple of things going on here. First off, we know we're going to be down here in quadrant 3. And because sine of theta is 3 over the square root of 13, we know that means the opposite is 3. The hypotenuse is the square root of 13. And we're looking for cosine of theta over 2. And that formula is cosine of theta over 2 is plus or minus the square root of 1 plus cosine theta all over 2. So we need to know what cosine of theta is. To find that, we'll use our Pythagorean theorem. Pythagorean theorem says that the square root of 13 squared is equal to 3 squared plus, we'll call it our x value squared. That gives us 13 equals 9 plus x squared. 4 equals x squared. So x is going to be plus or minus 2. And since we're in the third quadrant, or since we're on the left side of the graph, we know that x is going to be negative 2. So cosine of theta is negative 2. I'm sorry, negative 2 over the square root of 13. And from there we get cosine of theta over 2 is going to be plus or minus the square root of 1 plus negative 2 over the square root of 13, all divided by 2. So cosine of theta over 2 is going to be plus or minus the square root of 1 would be the same as the square root of 13 over the square root of 13. So that means what we've got here is the square root of 13 minus 2 over the square root of 13 all over 2. And if we invert and multiply, think of this as 2 over 1. And recalling that all of this mess is underneath the radical, gives us that cosine of theta over 2 is plus or minus the square root of the square root of 13 minus 2 over 2 square root of 13. And we can rationalize the rationalize the denominator on this if we want to, giving us multiplying both top and bottom by the square root of 13, we get 13 minus 2 square root of 13 all over 2 times 13 would be 26. Not pretty, but true. Thinking back, if theta is in quadrant 3, in other words, theta is between pi and 3 pi over 2, then that would mean that theta over 2 is between pi over 2 and 3 pi over 4. So it's in the second quadrant. And angles in the second quadrant have a negative cosine value, so we're going to keep the negative, and our final answer is cosine of theta over 2 equals the square root of 13 minus 2 square root of 13 all over 26. One more example. This one will be using our power reduction formula. Find an expression equivalent to 40 cosine to the fourth of theta using the power reduction formula. Now we don't have a cosine to the fourth of theta or of u formula, but we do have a cosine squared. So let's rethink what this is. And again, a lot of what we're going to be doing is rethinking these. 40 cosine to the fourth of theta. Let's think of that as 40 cosine squared theta times cosine squared theta. And now that we're looking at it this way, we can rewrite it as 40 times 1 plus cosine 2 theta divided by 2 times 1 plus cosine 2 theta divided by 2. And when we multiply that out, we get 40 times, this will all be over 4. And when we multiply 1 plus 2 theta times 1 plus cosine 2 theta, we get 1 plus 2 cosine 2 theta plus cosine squared 2 theta. And 40 and the 4 we can divide out, giving me 10 times 1 plus 2 cosine 2 theta plus cosine squared 2 theta. Now there's only one problem with this. We've still got a cosine squared in there, so let's get rid of that one. To do that, I'm going to go ahead and distribute the 10 just because I don't want to have to deal with the brackets. We get 10 plus 20 cosine 2 theta plus 10 cosine squared 2 theta. And our formula for cleaning up a cosine squared of something is to, let's see, I'm out of room. There we go. Is to use this formula, so we get (10) plus 20 cosine 2u plus 10 times 1 plus cosine. If we've got a 2u here, then if we've got a 2u here, then this is going to be a 4u, isn't it? So it's going to be 1 plus cosine of 4u all over 2. So our final answer is that 40 cosine to the 4th of u, or sorry, of theta, is 10 plus 20 cosine 2 theta plus 5 plus 5 cosine 4 theta. Again, the 10 and the 2 divide out, and I've got a 10 and a 5, so I can do a little cleanup. And final answer is 15 plus 20 cosine 2 theta plus 5 cosine 4 theta.